Okay, let's get a example with these matched pairs. So, Professor Andy Neal measured the time in seconds required to catch a falling meter stick for 12 randomly selected students' dominant and non-dominant hand. Professor Neal wants to know if the reaction time to an individual's dominant hand is less than the reaction time in his or her non-dominant hand. A coin flip is used to determine whether reaction time is measured using the dominant or not dominant hand first. Conduct the test at 0.05 level of significance, and the data is right here. So that's what it is. So this is what makes this one matched pairs. So I am catching the same meter stick. It is the same student. One single sample, if you will, and then within this sample, I'm looking at dominant and non-dominant hand within that same unit, right? Okay, that's what makes this matched pairs. The hands go to the same sample, and that's why it's matched up. All right, so this is what makes this one matched pairs. Just so that you know how to be able to identify this. All right, so here's the other thing. Let me fling back over here for a second. Look at all of these options that are available to us, or that we have to get taken care of. The sample is obtained by simple random sampling or data from matched pairs. Boom, nailed it. The data samples are dependent matched pairs. The right hand and left hand, dominant, non-dominant, right? So that's matched up there. The differences are normally distributed with no outliers, or the sample size is large enough. How many is in our sample? 12. Is this large enough? No. So we're going to have to determine normality, which is why I put these on here for us, just to make sure we're on the up and up. Then it says the sampled values are independent. The sample size is no more than 5% of the population. Yeah, we get that. There are more than 12 students out there, so we're good with the sample size. But I'm going to make this bigger here. Do we have any outliers? No, with these differences, we don't have any outliers. We are good to go, right? A good correlation with our normal probability plot of differences. So we're good with all of that. All right, so here is the deal. When we do these matched pair design, all right, you are going to have one column and another column, one variable and another variable that all go off of the same thing. But what is our focus? Do you remember our focus? The differences. Our focus is always about the differences. All right? So what we are actually doing, and in this instance, it tells us we're going to take dominant minus non-dominant in order to get a value. So let's go through here. On your handy dandy calculator, 0.177 minus 0.179, what's that going to get you? I'm going to scoot this equal sign over a little here, because I'm going to put my values right in here. I'm going to put an equal negative 0.002 and do it for all of them, right down the line. 0.210 minus 0.202 is 0.008, right? So this student 1 is independent, student 2 is also independent. And that's why we don't say right hand, left hand. Because if you're left-handed, that's your dominant hand. If you're right-handed, that's your dominant hand. So then your other one makes that impact. And that's the whole point, right? Which one do you think is going to be faster? Is your dominant? Your non-dominant hand, in theory, will not be as fast. All right? Okay, so check it out. But that's what the hypothesis is testing. Hey, does it matter? That's what old Professor Andy Neal's trying to figure out. Does it even matter if you grab it with your dominant versus non-dominant hand? Does it even matter? That's what we're trying to get figured out, and that's what we're trying to work with here. Okay, so do all these subtractions. And we're just literally going to go through here and then do these subtractions. Negative 0.022, 0.005. Keep going, keep going. Negative 0.017, 0.001. Check and make sure I'm doing these right. 0.034. If we're getting something different, then you're going to have to let me know. 0.043, negative 0.012, negative 0.020, negative 0.025. All right. All right. Those are what we have for dominant. Now, we've got all that set up, and we're trying to figure this out. So what the question wants to know, professor here, where is he? Wants to know, let's underline it. If the reaction time in an individual's dominant hand is what? Less than the reaction time in his or her non-dominant hand. So as I set up, this is the mean will always equal 0. Oops, the mean of the differences. That's important. I almost forgot my D there. The mean of the differences is always going to equal 0 because that's what we try to figure out. That's what we're saying is what we're starting with on matched pairs always. Then I want to say, is it? Is one less than the other? Ooh, I think the differences here are going to be less, is what we're talking about because it says less. All right? So that's what I want to figure out. My time is going to be less because my dominant hand is going to grab it quicker. So my time will be less is what we're trying to test to determine if that is what is actually happening. All right. Okay. We are going to use StatCrunch for this. So we have steps to go through in StatCrunch. So I'm going to write those down here just so that we can see it. Where am I going to write it? Over here. I'm going to say StatCrunch. So, because this is a mean, where are we going? Stat, then what? T-stats. Good. And then, because these are matched pairs, then we're going to click paired. All right? Okay, now, so in order to save us on time, so you're not just watching me plug those values in, now we're going back. Let me scoot this over. Remember, way back in stat, with the very beginning, this whole entire semester, you've been using StatCrunch. If you're going to have this double box over here, you double click on that. That goes into StatCrunch. It full on opens your data. For us, in our notes, we got to type it in. Just because that's where our notes are coming from. But that's fine. We can do that. So we're at stat because we're talking about mean. And look, there it is, paired. So stat, T-stats, and then paired. So whenever I'm pairing this up, let me scoot this up so you can see the whole thing. I'm going to go with my first column that I have plugged in there, my second column that I have plugged in there. And this order matters because you're taking a difference. That order matters. If we wanted to say non-dominant minus dominant, get off of there. Non-dominant minus dominant, then you would have to set those up that way, right? It's not always the first minus the second. Sometimes, depending on how your data is laid out, you have to swap that around. I'm going to save my differences because I want to see what that looks like. And then here's my hypothesis testing. And I want it to be less than. Notice it's already set up as 0 because we're looking at our differences. And it even has a nice little setup here where I'm saying my differences are my first mean minus that second one of the values that I'm looking at. Okay, so compute. And here's the other thing. I want to show this to you. See this? I put that we're going to save the differences. So then we have those right there. I'm going to, can I get them both in here? Well, you have them on your paper, right? These differences right here, these are the same that are in this last column. So yes, you can do those individually. Yes, you could set it up as long as you say save the differences and it'll do all the differences for you. But what do we really want out of this deal? We want to get the p-value. So our p-value is 0.009. To bring it back. So the p-value is equal to 0.009. Now what's that criteria again associated with my p-value? If it's less than my level of significance, then we reject. If, let's write it out just to make sure, is less than my level of significance, we reject the null hypothesis. Right? That's just the criteria that we've been using because that's the p-value approach, right? That is what it is. So let's see what's happening here. I've got 0.009. Is that less than my level of significance, which we know is 0.05? We know it right here in our problem. Is it? Yes. So remember, if the p-value is infinitely small, then that works. So we reject the null hypothesis. Because of this, we reject the null. What does the null say? That there are no differences. So if we reject what we're saying, that there's no difference between the dominant and non-dominant hand, didn't we just prove with these 12 students that there is a difference? So we have to reject that. So there is sufficient evidence. Let's write it out. There is sufficient evidence to conclude that the reaction time, to conclude that the reaction time in the dominant hand is less than the reaction time in the non-dominant hand. Literally, are we doing the exact same thing we've been doing this whole time? Yup. There is sufficient evidence to conclude, and then you write out exactly what it is that we're talking about. What are we trying to show? That there's less reaction time in the non-dominant. Less than. The differences are smaller that we're looking at because we're taking the dominant minus the non-dominant. If it's quicker, then we have all these negative signs that we see. Because the difference is negative means that it's quicker that we're trying to figure out. This took more time. That's the time. This took more time. So whenever I do this subtraction, we should end up with negatives there based on what we figured out with our hypothesis test. Does that make sense? Okay, and that's what we're looking for with these paired pieces of data. That's what we're going for there. Cool, right? Man, it's so nice. Previous information into the current lesson, but you can see how it all relates, which is nice.